Hi, this recording is to help you with actually parametric equations part 2. This year is actually 10.4.02. Alright, we're mainly going to be working on eliminating the parameter, which just means changing from parametric mode to rectangular coordinates here. So you can use your graphing calculator to indicate which direction we should graph. That's perfectly fine. I'm more going to focus on eliminating the parameter with this mini recording because I'm confident that you can type numbers into your calculator and look at the graph. I'm more interested in can we convert it from parametric to rectangular. Okay. So again, substitution is key here. I'm going to start by solving for t in my first equation and then using substitution. So to get t by itself, you would have to multiply both sides by 4. And now let's substitute that in for t. So y equals 4x squared. So to simplify that, 4 squared is 16, and then x squared is just x squared. So we can graph this equation as well. So that is now in rectangular coordinates, because you're dealing with just your x and your y. For the next one, again, I want to solve for t. So to get rid of a squared root, we have to square both sides. So t equals x squared. Let's use substitution. So that means y equals 1 minus x squared. So again, you have a parabola that is facing downward and shifted up 1, I believe. Okay, so that's the graph that would go along with this one. For our next one, it's a little bit more tricky when we're dealing with trig. And what we need to do is remember our identities. Okay, so if I'm dealing with cosine and sine, I want to be able to get those by themselves because I know that sine squared plus cosine squared equals 1. So that's the Pythagorean identity that I am thinking of for this trigonometric equation here. Okay, so if I can get sine squared plus cosine squared together, and I can set it equal to 1 then. So for x, let's work on isolating just cosine theta. So to get cosine theta by itself, we need to subtract 4 and then divide by 2. So cosine theta equals just this right now. And then we can do the same thing for sine. We'd add 1, divide by 4. Okay, but that's just cosine and sine. If I look at my equation down here, I want those to be squared. So that is where the squared is coming into play. Okay, so we isolated cosine and sine, and now we're going to square those so I can create an equation. And now I'm simply using substitution. So y plus 1 over 4 squared plus x minus 4 over 2 squared equals 1. Okay. So then from here to get your graph, it's now in rectangular coordinates. We learn that this is actually a conic section because we're adding. We know it is an ellipse since it equals 1 over here and you're adding with the center at 4, negative 1. Okay, so we can graph that once we find that. But I'm more interested in can we convert that to the rectangular coordinates. Same thing with our next one. We want to think of an identity for secant and tangent. Well, the only identity that I can think of is your secant squared theta minus your tangent squared theta. And we know that that equals 1. Okay, so if I can solve for secant and tangent and then use that same idea that I did in the last problem by squaring it, I can substitute it into that identity. Okay, so to get secant by itself, I would have to divide each side by 4. And to get tangent by itself, we'd have to divide each side by 3. Okay, again, we will have to square those. so that I can get secant squared and tangent squared. I can substitute that into my formula to come up with this, right? Except now we can even jump a step further. If we want, we can, instead of writing this here, we can say 1. And they simplified it one more step by saying x squared over 16 minus y squared over 9 equals 1. Because there's a minus sign here, and it does equal 1, I know that that is the conic section of a hyperbola. But again, I'm more interested in coming up with this rectangular equation. Okay, the last one is a little complicated because we are dealing with logarithms here. Again, I want to solve for x, so I can use, or solve for t, sorry, so I can use substitution. To get rid of t cubed, we'd have to take the cubed root of both sides. Okay, so t equals the cubed root of x, which is the same thing as saying t to the 1/3 power, or x to the 1/3 power. I am just not on a roll here. There we go. Had the wrong variable there. So x to the 1/3 power. And then we can technically rewrite this as well, right? The 3, which is out in front of the natural log, can actually be brought up as an exponent. So we can write it as y equals the natural log of t cubed. And let's actually use substitution into this equation. Okay, so doing that, we get the natural log of x to the 1/3 cubed. When we multiply our exponents, that's just 1. 1/3 times 3 is 1. So we're left with the graph of y equals the natural log of x. And we can come up with that graph fairly quickly here, and we would get something like this.